You've been working on that iOS app for so long. Finally, the day has arrived where you think it's ready to be published to the App Store. My name is René, and with this recording here of XAM222, publishing an iOS app, I would like to guide you through all the steps that are necessary to really polish your app and eventually get it out there to everybody on Apple's App Store. We split this video in 3 sections. The first one deals with how to get your application ready for publishing. This is something that you have to do on every platform, no matter if that's iOS, Android or Windows Phone. However, here we're gonna talk about the iOS specific bits. The next thing is something that is a bit special on iOS. We have to sign our application. That means we gotta talk about certificates, certificate signing requests, something that's called provisioning profiles. All of this is in the second part. And finally, if all the local things are done, we are ready to upload our app to the App Store. For that, we're going to work a bit with the iTunes Connect website. In order to prepare our application, we're going to go through the build settings. Everything we do in this part is going to happen inside Xamarin Studio or respectively Visual Studio. Also, filling in meta information, like the application's name, is very important. Finally, don't forget to add the required application assets. You want to make sure that you have high resolution icons that look great on all the different iOS devices out there. Something that should be obvious, but we want to mention it here anyway, is the fact that in order to deploy an iOS application, you actually need a Mac. It doesn't have to be a puppy like the one you see here. Certainly everybody would like to have the Mac Pro, but a simple Mac Mini will do. Make sure that your Mac has enough RAM, it's got a fast hard disk, preferably an SSD. On this Mac, you have to install Xcode. Currently, Apple requires us to use Xcode 7. If a new version is released, usually Apple requires us to update pretty quickly. Xamarin iOS uses all the tools that Apple provides. Let's start by identifying the required meta information of our application. If you right-click the iOS application project in Xamarin Studio or pick the options from the context menu in Visual Studio, we have different tabs available that deal with iOS-specific settings. You can see here we have iOS Build, iOS Bundle Signing, iOS IPA options, and finally iOS Application. In the iOS Application tab, be sure to fill in the application name. This is what your users are going to see on the Springboard. Springboard, this is where the applications are launched from. The available space is very limited here. In average, I'd say you have something between 10 to 12 characters. If your application name is too long, iOS is going to truncate it. So you want to make sure you have a short, concise name. The next thing in here is the so-called bundle identifier. It is recommended to use a reverse DNS identifier here. For example, for us at Xamarin, that would be com.xamarin.application name. The idea of the bundle identifier is that it uniquely identifies the app to the device. It is not possible to have 2 applications with the same identifier on one device. Every application also has a version. Please note that we have 2 version fields here. One is labeled version and the other one is build. The version, this is what the user-readable version is. Sometimes it is referred to as the marketing version. This represents our release version. But imagine you've been working on this product for over a year. You're going to release it with version 1.0. But internally, you already had 23 other releases. So your build would be 23.0.0. Apple does not dictate what our version strings should look like. However, it is recommended that you use the dot-separated numeric format. Let's now switch over to the iOS build section. In there we find the Advanced tab. Here we configure things like what compiler do we want to use? What sort of binary do we want to deliver? So let's quickly go through these. The first thing you should take care of is that you are using the Xamarin Unified API. Only with the unified API of Xamarin, you're able to deliver the required 64-bit builds. By default, if you create a new application, it should always be unified API. However, sometimes you might have to do with some older projects which is still using the classic API. In this case, you find an entry in the Xamarin Studio menu which helps you to upgrade your project to unified API. The supported architectures dropdown will decide what device you want to support. If you select only the 64-bit, which is called ARM64 here, it will restrict you to use the latest devices. The compiler selection decides whether to use LLVM or not. The LLVM compiler generates more compact and tighter ARM code, and it's going to perform slightly better. However, this is something that can only be used in release builds. It does not work in combination with the debugger. And finally, turn on the simple generational garbage collector, also called sgen. This provides a true generational garbage collector that's tuned for smaller and shorter collections. Because remember, whenever the garbage collector is running, your application is not. So you want to keep the garbage collector's intervals to a minimum. Make sure to configure these settings right away if you start with your project. And then go ahead and regularly create builds based on this configuration and give them to your quality assurance department. Only so can you make sure that they really test what's later going to be on the App Store. Don't let them use the debug builds. The debug and release builds, they are really very different. The release builds have all sorts of optimizations turned on. They behave differently. Switching over to the General tab lets us select the current SDK version. Unlike on Android, where we have up to 20 different APIs and SDKs to choose from, typically on iOS there's only one. If Apple releases a new version of their operating system, you might end up having two selections in there. If you pick the entry that says default, it's always going to point to the latest. And let me tell you a story. It happened to us back in, I think it was 2011. There was an upgrade from iOS 5 to iOS 6. And our setting there was default. So it was one of these scenarios where in the evening everything worked, we created our build, and in the morning the build would fail. And we had no idea what happened. And you all know the situation. Everybody says, I haven't changed anything. And really, source control didn't show a single thing that was different. Now what happened? Well, in the evening I installed the new SDK. And this was a preview SDK. So now I had the SDK 5 and SDK 6, but the setting was pointing to default, which now suddenly meant iOS 6. And iOS 6 had some minor but important changes that broke our build. Long story short, my recommendation is select the SDK version explicitly. Pick the version that you're working with, and if you install a new one, make sure to build with that and make sure that your application still works with the new SDK version. You don't have to worry about compatibility. The SDK version does not define on which platforms the app is going to run. You can use SDK 9 and still target iOS devices that run older versions of iOS. If the SDK version does not influence what devices we can run on, what does? Well, we find this setting in the iOS application section in the Summary tab. In there, you see a drop-down that says Deployment Target. This defines the minimum version that your application requires. I would like to now move over to Xamarin Studio to show you the different options live in the application that we are going to publish today. I picked one of the applications from one of the Xamarin University classes, and you might recognize it. Let me quickly run it. We have it here on the simulator. It's the Simpsons Contacts application. Here I'm running it on the iPhone 6s, and I'm just going to take this app because I think it's a pretty nice app, and I want to today publish that. Of course, it's not really going to end up in the App Store. We're not going to make it available to the public, but we'll go through all the necessary steps. Now, let me switch back here, and we want to have a look at the properties. I enter the options of the iOS project and I start with the iOS build section. Remember to switch the configuration to the one that you want to use later for release or for App Store. Typically, you're going to have two configurations. Release is what you want to use for all release builds, and you can have a more specialized one for App Store. The settings should be identical. So let me go ahead and configure the App Store one now. App Store is only available for the iPhone platform. You cannot create an App Store build for the simulator. In the General section, I recommend you explicitly select the SDK. The linker defines how much of your application is removed in case something is not used. The linker checks all of the methods, all of the libraries, all of the assemblies that you are using versus the ones that you are not using. The options that we have here is don't link at all, which will result in a much bigger package. Link SDK assemblies only, and link all assemblies. It's pretty safe to use link SDK assemblies only. The chances that something gets removed that you are using and the linker does not detect are actually really low. If you want to squeeze out all the bytes, you really want to get your app size as small as possible, you want to pick link all assemblies. Please keep in mind that this is also going to link third-party assemblies. In a project that I was working for, we had a PDF library. And we forgot that we had this option on here in the release builds, and the linker did not detect how many methods inside that library were really used. There was a lot of reflection going on. So it removed a lot of code that was actually required at runtime. And you will only notice if you hit that particular code branch, and then your app is going to crash. So if you want to use this option, be sure to test from the very beginning with this option on. My recommendation is to link SDK assemblies only. For every release build, you want to optimize ping images. iOS is very efficiently managing ping images. Debugging options, they should always be off for release builds. Not only do the binaries get significantly larger, it can also be a security issue. Now let's switch over to the Advanced tab. The supported architectures should be ARM64, but if you want to target older devices, you probably also want to include 32-bit ARM v7 code. This is going to make your binary again a bit larger, but you got to think which devices do you want to target. Do me a favor and always turn on the low-level virtual machine optimizing compiler, the LLVM. It's not compatible with debug mode, however, it should be used for all release builds. Using thumb2 instructions, well, this can save you a couple of bytes in app size, however, it's not making your app faster. The SGen generational garbage collector should always be on for all builds, no matter if it's debug or release. The performance is just much better compared to the older garbage collector. Now let's move on to the bundle signing part. We don't have to do anything here yet. Later, when we have discussed it, we have to pick the correct certificate here to sign our application. In the IPA options, you can go ahead and say, for every build that I make, please automatically create an installation package for me. This takes extra time during the build process, and often it's not necessary. We're going to create the package manually today. Here in iOS application, we want to set up the application name. Remember, pick a concise name with 10 to 12 characters. Maybe we want to call this our Simpsons contacts and see if that fits on the screen. I presume it's going to be too long. We're going to test that. We want to use a proper bundle identifier. Remember, this has to be unique per device. So let's set that to com.xamarin.simpsons contacts. This is our marketing version. We're going to release 1.0.0. Our build in this case is the same, but let's just say we've been working on this for a while, so we make this version 7.5.4. I'd say our application is a typical phone app, so we're going to restrict this in this case to iPhone and iPod. Our deployment target is version 6 here. Well, the Contacts app really is a Xamarin Forms app, and Xamarin Forms works on all iOS systems down to 6.0. So we're going to use 6.0 here, even though our SDK is set to version 9. This really is just a promise. We say we're not using any APIs that are available only in higher versions. I'm going to show you in a second how Xamarin Studio supports us here. Down here, we have to pick the supported orientations. For an iPhone-only app, every orientation is supported except upside down. It would work, but Apple defines in their human interface guidelines that upside down is something that you should only use on iPad apps. Down here, we set up our icons. Currently, our application doesn't have any icons. I'm going to show you that in a second. We got to fix this later. Likewise, we do not have any launch images and no launch screen. You're also going to see how this affects our app and how we can fix it. The iTunes artwork, that sounds a lot like it is something that we should add if we want to put our app on the App Store, because we visit the App Store via the iTunes app. However, this is a bit misleading. iTunes artwork is only used if you distribute your app manually. If, for instance, you use an enterprise build and you put the app somewhere on the server, or you send it to somebody and they install it via iTunes, then it's going to show these icons here. Down here, we have to configure whether we use maps and if we use any background modes. Our application does not do that, so we're done here. Now everything's set up. I want to click OK. Now I'm going to switch to the app delegate, and I want to show you how Xamarin Studio supports us here with the different SDK versions. We have defined that our iOS level that we want to use is 6.0. Now watch what happens if I use some API that is not available in iOS 6. I want to use the new UI alert controller, which has been introduced with iOS 8. I new up the controller and I want to present it. Now look at this blue line here. If I hover the alert controller, it tells me, hint, this API requires iOS 8.0 or later. Xamarin Studio detects that we are targeting 6.0, and it tells us if we run this application on a device that is not running at least iOS 8, this is going to be a problem. Here, it's simply going to crash. However, it does not prevent us from using it. What we can do in this case is use some check-in here. In the UI device class, we find a static property which is the current device. The current device comes with a pretty nice method which is called check system version. In here we can provide a major and a minor build number. So we want to say that we only want to make sure that the alert controller is used on iOS 8 or above. So let's use 8.0 here. Now if the device runs iOS 8 or above, this method is going to return true. So now it's perfectly safe to use the new UI alert controller. We can be sure that this branch is only going to be executed on iOS 8 and above. In the else branch, we could now go ahead and use some alternative way. Before iOS 8, this would be the UI alert view. Let's now check if our application name fits on the Springboard screen. So here we have the app running. I want to press the home button, and you see that was too long. It says Simpsons ... This is something we certainly don't want to see in a productive app. Thinking about it, I imagine that Apple would reject that. Another thing that is very obvious here, that we don't have an icon yet. That's not very pretty. So let's fix these things. But first, let me show you something else. I want to quickly terminate the app here. So it's really going to be restarted if I tap it. Now watch what happens if I select that icon. We see a black screen, and shortly afterwards, our application appears. Let me show you that again. I'm going to terminate it, and I want to start it. Black screen, and it takes a long time, and here we have our UI. Now that's not a very good user experience. Our users might think something went wrong. The app does not react. We go back to Xamarin Studio. We want to fix the name, add some icons, and also change that behavior during startup. Let's start with the options here. In the iOS application settings, we want to rename this here maybe to just Simpsons. Keep it simple. And then let's fix the icons. You see that down here we can select icons for each and every possible iOS device. That's quite a lot meanwhile, and it can be quite tedious to manage them all. We got to provide them both in normal resolution and in retinal resolution. Here you see that's indicated here by the add 2x suffix. We can alternatively also use an asset catalog. Asset catalogs allow us to more easily manage different assets like icons. So that's what we want to do. This is what I would like to use as an icon. You see, it's just a square ping image, and there are websites who help us to create all the required icons, so we don't have to go through this process manually. The one that I want to use today is called makeappicon.com. If you navigate to that website, it asks you to simply upload an image, and you can then pick whether you need images for iOS or for Android. Here I picked iOS, and you see it generated all these different icons for me. I can then go ahead, enter my email address, and it's going to send me the icons. And what I received there is actually an asset catalog that I can use directly in Xamarin Studio. I want to prepare my application now for the asset catalog. We go to the options again, into iOS application, scroll down to iPhone's icons, and where it currently says don't use an asset catalog, I'm going to say create asset catalog. And it automatically creates a catalog that's called app icons. I'm going to confirm here, and we see a folder has been added here into the resources. It's called images.xc assets. If I expand it, we find an appicons.appiconset folder. In there, there's one JSON file. This JSON file defines what icons are used for which particular device. I can double click that here, and Xamarin Studio gives me a nice overview. Currently, there are no icons declared in here. We want to change that by importing what we have just downloaded from this web application. Before we can add the file that we have just been emailed by the website, we want to remove the contents.json file here. Otherwise, Xamarin Studio is going to complain that it cannot replace it. So let's delete that. Now I switch over to Finder. I select all the files, and I want to drag them in here. A dialog is going to pop up that asks me whether I want to copy, move, or add a link to the file. We want to make sure that all the files are going to be part of our solution, so let's copy them. We can now expand them, and we want to double check that the build action is set correctly. Let's right click here, check the build action. It should point to image asset. Now let's run our application again. If the application has started, I'm going to press the home button, and we see that our Springboard entry has changed here. Now the app name nicely fits there, and we have an icon. What we haven't fixed yet is the problem with the black startup screen. Let's go back to the options once more. Down here, we can provide launch images. A launch image is what iOS shows while the app is initializing. This increases the perceived performance a lot. For differently sized phones, we have to provide different images. The iPhones come with different resolutions. Now you can imagine that the more phones we support, the more iOS devices we support, the more images we're going to have in there. Now every image is going to take up some space, and it's getting harder and harder to maintain all these images. So alternatively, what you can use as of iOS 8 is a launch screen. A launch screen is actually a storyboard or a zip file. In the drop-down here, it offers us one entry, which is called Launch Screen. Let me show you where that came from and how to use it. In the resources, we see the launch screen.storyboard. If I double-click that, it's going to open up the storyboard editor. Inside the launch screen, you have limited functionality. Here I used it to create a view which contains an image of Homer, and the view uses auto layout constraints, so it nicely adjusts to different screen resolutions. I only have to create that once, and it's going to look good on all the different devices. Here you see how it's rendered for the iPhone 4. Let me switch to the iPhone 6. You see it scales it nicely. The 6 Plus. Or the iPad. It's always centered. It's always using up the screen as good as it can. Let's try to relaunch our application with that storyboard with this launch screen in place. Back on the simulator, I tap the app and we see Homer, and when it's done loading, it switches over to our UI. Let's wrap up this first part. We've seen there are quite a lot of settings that we can tweak and have to tweak inside Xamarin Studio to get our build ready. We have to fill in a lot of metadata. We set the application icons. I showed you how to create an asset catalog and also how to design a launch screen that nicely adjusts to different resolutions. The next step is to sign our application. To publish an application out there to different devices, it is necessary to sign it, no matter what type of publishing we choose. The most common one is certainly where we're going to upload our app directly to Apple for distribution. But we want to see that there are other types of publishing. There are actually three primary ways to publish our applications. The first one is called ad hoc. This is what we use primarily for testing. The idea is that we identify a set of users together with their non-developer devices, and we invite them to install our app, and they're going to give us feedback. There's a limit on the number of devices that we can deploy to for this scenario. As of this recording, the number is limited to 100 per year. The most famous approach is to deliver an app to the App Store. That's probably what you have already seen and used if you have any app on your iPhone. With the App Store publishing, Apple markets and manages the application for us. There's another publishing type that is not so well known, that is enterprise deployment. The idea here is that we can deploy an application for internal corporate applications. This means as a company, we provide an app for our own employees. And this model allows the app to be installed on an unlimited amount of devices, and the devices don't have to be identified either. As already mentioned, ad hoc deployment is where we are allowed to selectively identify a set of devices. This happens via the unique device identifier, or short UDID. If the devices have been identified, the app can be installed only and only on those devices. Like already said, the number of devices is limited to 100. However, this is a limit per year. That means you can register up to 100 devices, and if immediately afterwards you remove all the 100, you cannot add any new ones. You're essentially left without any devices. Once a year, Apple allows you to reset the list or remove devices. Also, something that is often used together with ad hoc publishing or testing is TestFlight. TestFlight used to be an independent site, and Apple acquired that site. And with TestFlight, the process of identifying devices gets greatly simplified. TestFlight helps you to upload a build to Apple. You can invite testers directly, and then they get informed that a new version of an app to test is available. We can have a look at the TestFlight UI a bit later. App Store publishing is the most common deployment method. This is where we upload our build to Apple servers, and then people can find our application in the App Store. And this is the single shopping point, unlike on Android, where we have different stores. There are more than 1 million applications in the store at the moment. And Apple manages not only the hosting, but also the distribution, the payments, if there are any, and it calculates monthly profit sharing. The App Store also allows to create bundles, where you can grant discounts on. It also offers something like trials, in-app purchases. And finally, there's enterprise publishing. Like I already said, the idea here is that it allows companies or enterprises to build applications for their employees. It is important to know that this does not utilize the App Store. And unlike applications that go through the App Store, which have to be reviewed by Apple's team, an enterprise app doesn't get through any review process. Instead, it can be installed on any device, and this happens either through iTunes or even over the air by surfing to a specific URL on the browser on the iOS device. Now, you might say that's very tempting to use that and essentially bypass the App Store. However, a word of warning here. Apple is very strict on allowing this type of publishing, and the sign-up process really is a bit tough. Obviously, they don't get any money if you use that type of publishing. And of course, they also want to prevent that users bypass the App Store. There's a very famous example out there, which is the Game Boy emulator for iOS. The makers of that, they used an enterprise certificate to publish the app. And it didn't take long until Apple pulled that certificate, and then they banned them completely from the App Store, and they removed the developer account. So do me a favor, don't abuse this system. No matter which distribution style we select, the process of creating a distributable app is pretty much always the same. First, it is important to know that we must be enrolled in the Apple Developer Program. And for an individual developer, this costs $99 per year. And for an enterprise account, it's $299 per year. Now there's an exception to this rule. With the new iOS 9 and Xcode 7, it is possible for any user who has got a regular Apple ID to download projects, build them in Xcode, and deploy them directly to the device. Before iOS 9, this was only possible when deploying to the simulator. Now, this limitation has been removed. So essentially, everybody can now try to deploy an app to their devices. But let's just assume we want to really publish our app here to a greater audience. Then we need the paid accounts. We're going to need a set of certificates. In general, a certificate is meant to create trust between the developer and Apple and the end user. So we got to set up a couple of them. We need a distribution or App Store certificate. And this is what allows the app to be installed onto any device. We're also going to need an application ID. Every app ID uniquely identifies one single app to Apple. Here we're going to associate the bundle ID that we already have set up in Xamarin Studio, and we combine it with a server identifier. The result is the app ID. We're also going to need what's called a provisioning profile. The provisioning profile is really something that puts together the distribution certificate, the app ID, but also the devices where our app can run on. You can think of the provisioning profile either as a box where we throw everything in, or as the glue between these components. We will then sign our app with the distribution certificate. We're going to combine it with the provisioning profile. We're going to create the app, and in the end, what we get is a zip file. The zip file contains our app, and we can distribute it either internally or through Apple's iTunes Connect system for App Store publishing. And if this whole process looks complex to you, I can assure you it is. But there's really a rule behind this. You have to keep in mind, only Apple can allow an iOS device to run a certain piece of software. All of the certificates, they're really Apple's way of controlling what software is allowed to execute and how iOS verifies the authenticity. The provisioning profile is what holds everything together. It serves three purposes. First, it connects a specific signing developer or distribution certificate with an app ID and a set of devices. It's also used to verify the integrity of the built application. So the provisioning profile is going to be part of the packaged app. And in the provisioning profile, there's going to be cryptographic hashes of all the files that are in the package. So if you try to modify a file in the package, the cryptographic hash won't mesh any longer, and iOS is going to refuse to start the app. You can have provisioning profiles for different purposes. The first one is the developer provisioning profile. That's used to allow the debug applications to be installed on any developer devices. That means devices that are registered with Apple that are associated with the same developer's email as the actual certificate. We also have ad hoc provisioning profiles. They have a specific set of devices. And we already talked about this. These devices are identified through the device's unique device identifier. We can manually change this list in the Devices tab in Apple's developer portal. The actual app bundle, the IPA that is generated in the end of our distribution process, is something that can be sent to a user who owns one of the identified devices. They can then simply go ahead and install the IPA directly with iTunes by dragging and dropping it, or they can go ahead and point their devices to a specific manifest file on a server, and then they can install it over the air. The third option here is the App Store provisioning profile. That's what is used to identify an app that can be distributed through the App Store. Ultimately, it allows any device to run the application, but only allows installation through the App Store. And essentially, this works is that it's using a temporary signature. The profile that we have here is used to sign the app so that Apple knows the developer when it's uploaded. And once it passes the review process, Apple is going to re-sign the application with their own very secret internal certificate. And this makes sure that it's available on the App Store and installable on all of the devices. Lastly, we still have the enterprise provisioning profile. Just like the one for App Store, it allows us to install the app on any device. However, these type of applications, they don't have to be downloaded through the App Store. They can be distributed either by email, via server download. And this is what is used to create applications inside enterprises for employees. We want to have a look at the entire signing process now both in Xamarin Studio and also in the developer portal. This is what we see and what the website currently looks like if we navigate to developer.apple.com. Here you see it. In there we find the Member Center. That's where we can log in. I'm going to use my privately owned account here for this demo. Since I'm a member of two teams, I have to pick here which team I want to work for at the moment. I'm going to pick the private one here and tap on Continue. Now this is the overview that you have already seen on the slides. Here I have access to all the latest SDKs, the certificates, identifiers and profile section that we'll be working with today. It can directly take me to iTunes Connect. We're going to see later how to use that. And I can use the forums, the bug reporting tool and request technical support. Let's enter the certificate section. Again, it asks me to select the team here. And it gives me this overview. Apple provides certificates for iOS apps, for Mac apps, and we can also work on Safari extensions. Now, since we are focused on iOS today, let's pick this one. You see, currently, I do not have any certificates installed. Here's a short explanation how to get started with iOS certificates. We can either manually generate certificates, pressing the plus button up here, and we have to select what type of certificate we want to create. Do I need one for iOS app development? Do I need one for the push notification services? Or do I need a production certificate? Like I want to distribute my app to the App Store. Ultimately, that's what we want to do today. But first, let me quickly show you how to set up the initial certificates that we need for development. The easiest way to do it is through Xcode. We have a lightning lecture about that, which you can find at university.xamarin.com. But let me quickly switch over to Xcode. In Xcode, you can open under the Xcode menu the Preferences dialog. There you find the Accounts tab. In there, it allows you to log in with exactly the same Apple ID that you have just used at developer.apple.com. It shows me the same teams here. I'm going to pick the one that I have currently open in the browser and view the details. Xcode now communicates with the dev portal and sees what type of certificates exist there. It recognizes that currently there aren't any certificates. In here, I can easily go ahead and create one for development. When it's done, the Create button disappears. Likewise, I want to create a distribution certificate. You see that I also could create certificates here for Mac development. I'm skipping that since we want to focus on iOS here. Down there, you already see a list of provisioning profiles that exist in the dev portal. Let's switch back to the browser. I refresh the certificate section here, and you see that it has generated 2 certificates for me. One for development purposes, one for distribution. You can tap them for details. In the dev portal, we can download the certificates. However, since they are managed through Xcode, this is not necessary. They have already been added to our keychain. We can verify that by running the Keychain Access app. If you select the My Certificates section, you find that there's an iPhone developer certificate and an iPhone distribution certificate. Note that it also contains a private key. The fact that Xcode automatically manages the certificates for us is certainly nice. However, it's also good to know that there is a manual process that you can follow in case something goes wrong. I'm here in the Production tab for the certificates. Up on the top right, you can see this little plus button. This allows you to add a certificate manually. Let's quickly go through the wizard here. I can decide what type of certificate I want. Let's say we want to create one for App Store submission. I scroll down and select the Continue button. Now, the wizard cannot be completed online directly. Instead, we are now asked to create a certificate signing request. The certificate signing request is issued with the Keychain Access tool. So I'm going to run this, open it, and in the menu, I find the certificate assistant. In there, I can request a certificate from a certificate authority. Now it asks me for a bit of information about the certificate that I want to create. So I'm going to enter my email address here, and I'm also going to use that as the CA address. Be sure to save this certificate request to disk. I want to save it here directly to my desktop. Once the certificate request has been created, I can use it and upload it to the dev portal. I switch back to the browser, continue the process, and choose a file for upload. The file that I pick here is exactly the one that we've just created. Let's click Generate to create our certificate. Once the uploaded certificate signing request has been processed, we are now ready to download our certificate. By downloading it, we're going to add it automatically into our keychain. I'm not going to do that here, since I already have a certificate that's managed by Xcode. The first part is now completed. We have our certificate. Now let's go ahead and create an application identifier. You switch over to the identifier sections and select App IDs. You can see that I already have a couple of apps in here. Now let's add the new one for our Simpsons contacts. This has to be done entirely in the browser, so there's no automatic support through Xcode or Xamarin Studio. We click Add to register an App ID. Here we can give an App ID description. This is only used within the dev portal. This is nothing that's going to be shown to the end users. The App ID prefix is something that together with our bundle ID, remember that's what we entered over in Xamarin Studio, is going to generate our completed App ID. The next thing we have to enter here is the App ID suffix. Note that we have 2 choices here. We can generate an explicit App ID or a wildcard App ID. The wildcard App ID allows us to reuse this App ID for multiple applications. For instance, com.xamarin.star. This will work for all applications that start with a bundle ID of com.xamarin. The question now obviously is, why is there this choice between wildcard and explicit App ID? Why would I ever create an App ID that only works with one specific app? Well, we find the answer down here. Here's a list of optional app services that we can use. You probably know Game Center, HealthKit, HomeKit, also things like Apple Pay. Notice that all these services are disabled. However, if I switch to an explicit app ID, they become available. The bundle ID is part of the app ID. So we have to enter exactly the same bundle ID that we already use in our app. Let me switch over to Xamarin Studio. In the properties of our iOS app, we find the bundle identifier. It's com.xamarin.simpsonscontacts. We want to copy this. And over here, we're going to paste it. Our app is not going to use any additional services. So we're going to leave all of these unchecked. The final step is to simply press continue. It's going to generate the app ID and we have to confirm it. Here's an overview. We see this is the complete app ID identifier. It's the prefix plus our bundle ID. And it now shows up in our list of app IDs. Okay, we now have the certificate and we have the app ID. Now we have to identify the devices that we want our app to run on. Here you see the Devices tab. In here, I currently have a handful of devices registered. Now, if I wanted to distribute a test build, these are the devices that our apps would run on. However, since we are going to create an app that will be sold through the App Store, it's going to run on all devices. So we don't have to specify any here. And instead, we'll move on directly to the provisioning profiles section. Provisioning profiles hold everything together. The devices the app can run on, the certificate, and the app ID. Just like before, we have to create the provisioning profiles directly here in the browser. Again, we are asked what type of profile we want. We want to create one for distribution. The app ID is part of the provisioning profile. So now let's select the app ID that we have just created. It's the Simpsons Contact ID. And finally, we have to pick the certificate. There's only one distribution certificate, so that's an easy choice. The last step is to give the profile a meaningful name. Again, this name is not going to show up anywhere. So just pick something that helps you to remember which application you used it for. And we can generate the profile. The profile is now complete and it can be downloaded. Normally the download is not required. Instead, Xcode is going to pick it up automatically. So let's switch over to Xcode and see if it is there. In the preferences, we see that the Simpsons Contacts profile shows up here. It's pulling this information from the dev portal. I have already downloaded this one here directly in Xcode. But you see I created another one here, which I call testing, and Xcode shows the download button back here. So you can directly click in here to download it, or you download it via the browser and then double click it and Xcode is going to import it. We now have all the ingredients in order to sign our application. Back in Xamarin Studio, in the section iOS bundle signing, we have to pick the configuration that we want to change. Be sure to pick App Store here. The signing identity, that's the certificate that we want to use. The provisioning profile, that's what we have just created. Based on the installed identities or certificates and profiles in combination with our bundle identifier, Xamarin Studio tries to pick the correct identity. However, this can fail. So I recommend you pick the correct signing identity manually. In this case, it's easy. There is only one distribution certificate. The provisioning profile has to be matched with the signing identity. And we know that we created one explicitly for our Simpsons Contacts app. So let's use that profile. We are now ready to create our App Store build. This is really trivial in Xamarin Studio. In the Build menu, you find the entry Archive for Publishing. If I select that, Xamarin Studio is building the app and it's also going to archive it. In this screen, we see a list of archives. The idea of an archive is that it contains the application together with all the debug information. This is important. If you're going to receive a crash report for your app, you want to make sure that you have the debug symbols available. And it also helps you to keep track of the versions that you have created. If you're happy with the build that you have just created, let's go ahead and sign and distribute it. This is going to bring up a wizard. Xamarin Studio lets us choose whether we want to create an ad hoc build, an App Store build, or an enterprise build. We want to distribute through the App Store. It then asks me which provisioning profile to use. We want to pick our distribution profile and click Next. And it tells us that all the required information has been collected and our app can now be published. You see that now it's going to generate an IPA file. I'm going to save that to my desktop. The next step is to use the application loader to upload the application to Apple. The application loader is a tool that ships with Xcode. You have to log in first and then select to deliver your app and pick the installation package that we have just saved to the desktop. What we see now is that application loader tells us that currently it cannot upload the package. The reason is that we have prepared everything from a developer's perspective. However, we have not entered our App Store entry yet. This is what we're going to do next, and then we're going to come back to application loader and retry. All the steps that we have taken so far are in the responsibility of the actual developer. Now we start with the part where it's up to somebody, for example from marketing, who's supposed to set up everything on Apple's App Store. Once this is done, we can upload our application. In order to fulfill this, we got to explore a website that's called iTunes Connect. In there, we're going to fill in all the application data that is still required. And finally, we'll be able to submit our app. iTunes Connect is a web page that we find at itunesconnect.apple.com. You can log in there with the same account that you have already used in the dev portal. However, here in iTunes Connect, also other people potentially have access. It is used to supply application info, but also to get information about the sales of the app. Here you can also manage beta testing. Once you have started a new app, you will need to fill out all the details of the application. We have already heard that filling in all this information is very important. You want to make sure that people find your app. There are a lot of applications on the App Store, so you really want to make it shine. After the app has been created and assigned a name, we have about 180 days to upload. Since a lot of screenshots are required with different resolutions, maybe you want to use some utility. I can, for instance, recommend launchkit.io. This is where you're going to upload one screenshot, and it's going to generate all the different variations for different devices. iTunes Connect also supports Apple Test Flight beta testing. Here we can invite up to 1,000 external testers and up to 10 internal testers. The difference between external and internal is that in order to submit a build for an external tester, it still has to be reviewed by Apple. However, the review process is not so strict like the one that is used for publishing an app. However, it's still going to take up to 48 hours to review an app. Also, we are only allowed to upload a maximum of 2 different builds per day. Internal testers have to be members of your team. You have to invite them annually. Then you can directly distribute the build without going through the review process. If you're supporting multiple platforms, maybe also Android and Windows Phone, you want to have a look at other services that are not limited to iOS. One of them, for instance, is Hockey App. This is a Microsoft testing distribution platform. There isn't any forced approval process. You can invite testers through email, however, it's limited to 100 devices per app. Once our app has been built, all the information is available, we can go ahead and submit it for review. After it's been submitted, we can either release it manually or we can iTunes Connect let it release automatically. The review process typically takes something between 3 and 14 days. We want to have a look at the processes that we go through in iTunes Connect now directly. Here I'm logged into iTunes Connect. You can see we can access the apps that are already on the store, analyze our apps, check the sales and trends, and so on. We want to create a new app today. You see, these are the apps that are currently on the store under my account. Let's create a new one. Our app is going to be for iOS. We want to give it a name. Now that's the name that's going to show up on iTunes. We have to choose our primary language and a bundle ID. You see here, it lists all the bundle identifiers that we have created over at developer.apple.com. Make sure to pick the one that is correct for your application. The SKU is just a unique ID, something that is not visible on the App Store. After a short processing time, the app has been created. The information that we have already provided is here in these fields. You can still change the name, provide a privacy policy URL, you can change the bundle ID, add languages and localize, and also pick the pricing and the availability. iOS apps can't have any arbitrary price. Instead, you have to pick whether it's either free or it's one of the predefined tiers. Let's say this one is going to sell for $99. Everything we have configured so far affects the version that's going to be on sale in the App Store. The next section down here, you see the currently available builds. Here we have our version 1.0, which is waiting for submission. Every build or every submission that we have can have a new set of screenshots. Here I created the screenshots using the LaunchKit.io website, and I have already provided the necessary ones for all the different iOS versions. We must provide a description for our app. Make sure that this is something that is catchy. You want to make sure that people download your app and not some other alternative. You can also add keywords for search engine optimization. We must provide a support URL. That's where people can go to if they have problems or questions about the app. If we scroll further down, we see that currently no build has been uploaded. We're going to do that using Application Loader. Down here, we have to upload an application icon. The size of this icon must be 1024 times 1024. This is what the App Store will use to represent your app. We can provide copyright information, the representative of this app, and specify the version. This is the version that our users are going to see on the store. We already decided that we are going to use 1.0.0 here. Also, the rating is important. We have to define for which audience our app is suitable. We cannot directly decide. Instead, we have to answer this question here. In our case, the selected app rating is going to be ages 4 and above. That's the minimum. We can define if our app uses Game Center. It doesn't. And we have to provide some review information. The review team sometimes has questions. So let's fill this in. In case our application requires some sort of login, make sure to provide the demo account login credentials here. Our app doesn't have any logins, so we can skip that. Here you can provide notes to the review team. So if your app has some special features, maybe you want to give instructions here. And finally, we have to decide what happens once the app has been reviewed. We can release it manually, or we can have it released automatically. It's personal preference, but I typically release manually. There's also an iTunes Connect app for the iPhone. In there you can always see the current status of your app. And once it's been reviewed, you can release it from there. When everything's been set up, let's save. We are now ready to upload the application. Remember, here we stopped and we had this problem. Let's cancel and try to redeliver the app now. We select the installation package just like before. Application Loader now talks to iTunes Connect, and it detects that we have created an application that matches the information of the installation package. You can enable this Activity tab here, which shows you what is currently going on, what Application Loader is doing. By clicking Next, Application Loader starts analyzing the app, and it's uploading it to Apple. Once it's been uploaded, we have to switch back to iTunes Connect. I selected the application here, and I'm going to scroll down. The next step is to add one of the builds that we have submitted and connect it to this app here. You see down here, next to the build, we have this plus icon. If I tap it, it shows me all the builds that I have submitted with the application loader. I added quite a few here, so you see that they are all kept around. Once a build is uploaded, it takes a while for Apple to process it. Here, the version 1.0.0 is ready processed and we can use it. So I select it and click Done. This is now the build that's associated with our app. We can now save, and afterwards we'll be able to submit this application for review. We have to answer a couple of more questions. For instance, does our app use some strong cryptography? We have to answer these here with no. Do we display any third-party content? No, we don't. We do not use any advertising identifiers either. Now the Submit button is enabled and we can submit the app. Our app is now waiting for review. That means it's going to sit there and wait until somebody at Apple has a look at it. They're then going to check it out, and if there are no problems with it, they're going to approve it and we are ready to release it. We're not going to wait until this application has been approved or denied. We don't want to really push that onto the App Store. So I'm going to developer reject this build. Whenever you submit an app, you can say, nah, I'd rather pull it back. But let me show you the other features of iTunes Connect quickly. Here are the features. We can use and configure our in-app purchases and our Game Center content in case we would be making a game. In the test flight section, we can configure our beta testing. We can invite internal testers, up to 10 testers, which have to be members of our team. And we can invite external testers. Here we can add up to 1,000 testers. Again, the difference between internal and external is that whenever you want to submit a build that is testable by external testers, it will have to be approved by Apple. This approval process usually takes around 48 hours. Per day, it is possible to upload a maximum of 2 builds. There's one thing that is really nice about TestFlight compared to any other service that is out there. Here with TestFlight, you upload a build and you make it available to your testers. If you are happy with the test results, you can directly publish the exactly same build to the App Store. While with other services, you're probably required to rebuild from your source code and then upload the build to Apple. So there's a small chance that something goes wrong during this process. In the Activity tab, we see what's going on with our builds and with our App Store version. Now let's go ahead and develop or reject our build. Here's the link, which will remove this version from review. Please note, if you remove a version from review and you submit a new build, you are again last in queue. In case our app gets rejected, we will be informed by Apple. Apple provides a page where you can see the common app rejections. So these are the top 10 reasons. Often the reason is quite simple. Apple would require more information. So that means we didn't give enough details, how to test the app, how to log in, or it's simply missing some icons. This is an actual example of a rejection email. So you can see how closely Apple looks at the apps. Here in this case, a UI element was overlapping the UI status bar. This is not allowed according to the human interface guidelines that Apple provides. So be sure that you follow these guidelines. If you're interested in more details about the publishing process, please be aware that it's exactly the same process whether you deploy a Xamarin iOS app, an Objective-C app, or a Swift app. Apple has a lot of excellent documentation on the topic. You can reach all this at developer.apple.com. Let's quickly recap what we talked about. We have seen how to get the app production ready. We discussed the different types of publishing. There's ad hoc publishing, enterprise, and App Store publishing. And finally, we prepared our app for the App Store. For that, we had a look at iTunes Connect. We have reached the end of this video, and I would like to thank you for watching. If you have any questions, feel free to contact me. My email address is rene@xamarin.com. Also be sure to visit the Xamarin forums. One last tip: if you plan to create and publish an iOS app, prepare it early. Go through the whole publishing process and maybe even submit a dummy version of your app to Apple. Only with that experience you can be sure that when the day arrives when you are ready to release, that everything is going to work smoothly.